Welcome to Sound Maps tutorial. We will see in this tutorial how to define a sound map for an area of our scenario, which in this case will be the river. So the first step will be to create an empty game object, which will be the root of our sound areas. Under it, we're going to create another game object to which we're going to add the component fMappedArea. This component basically acts as the holder and area definer of our map. You can see it depends upon a box collider, and you should place it roughly around the center of the area you're going to map. We're going to use the bounds of the collider to define the area upon which the map is going to act, so be decently precise with it. Place it correctly in the space using an isometric view in the sim view of Unity. As you can see, we are going to encapsulate the area in which our player is going to walk with a decent height to it, so we are safe on that front. And with isometric view and from a top view, we are going to create a screenshot of just the box collider bounds. Here, according to your operating system, you might use different techniques, one of which could be that of capturing the whole screen and then in Photoshop cropping just the box collider bounds. Once you have the screenshot of the precise bounds defined by the collider, we can move to Photoshop. We open our screenshot and we will use this to basically paint over it our actual river map. I'm using a simple brush in Photoshop set to white color, full white color, and I'm roughly painting the river shape. Once you have the main shape defined, we need to add some kind of a gradient to smoothly fade out the sound. So I'm going to use the glow effect in Photoshop. You can find it among the layer style options, which helps me automatically creating a smooth gradient around the shape I have painted. Many techniques can be used to achieve this effect, and according to precision you require, you can obviously use yours. Next step is to create a black background layer, which basically defines where instead there is not going to be any sound from our map. So the map works in such a way that where full white is found, you're going to have the maximum volume. When instead full black is found, you're going to have zero volume. So the gradient helps us smoothing out this transition between full and no volume. We then need to save the map we've just created into our project folder in Unity, in this case in the Sound Maps folder. And once in Unity, we have to be careful with the import settings for this image. We have to enable read and write, disable non-power of 2 rounding, and also the MIPAPs, we don't need them, so I'm going to disable them. Apply the import settings, and we can now move on to actually use the map we've painted. In the River Sound Area game object, we will see a multi-dimensional maps array. Create one element for it, and inside it, one element for the maps array. I'm going to set the wanted map channel to white, since I've painted my map using black and white, and I want white to be the highest value possible. And I simply drag the map into the appropriate field, image data. Once I've done this, I can press from the drop-down menu Setup button, which actually grabs the data from the texture and creates arrays, sizes, and whatnot our component needs to operate correctly. You can now check your data in Unity 3D Space by enabling the Display Debug checkbox. Below it you can find some settings as debug side res and debug vertical res, which define the resolution of the debug display. You will see some very small green dots over where your data is going to be different from 0. And this view actually it's not very precise and actually quite slow to display in Unity, so use it basically only to verify that your data was imported correctly and applied correctly in 3D Space. We can now move on and create the actual component and game object responsible for playing the audio clips based on the data read from the map. So I create a new game object, and to this I add the component fMapAreaSound. This component has a sounds array which defines which audio clips will be played based on the data read from the map. The first element I'm configuring is a looping clip, which is a nice river flowing sound effect which loops correctly. I'm enabling direction, and this allows the audio source to be correctly placed in space based on the direction of the sound read from the map. The second element is going to instead be made of random clips. Here I can drop various audio clips. In this case they are simple bird sounds, and the sounds from this array will be picked randomly and played together with the other audios from this river sound game object and component we have just created. I have to leave the looping clip field empty, else the component expects to find a looping clip, but if that is empty, random clips will be used. Through the drop-down menu, I have to then select the Setup Audio Sources button, which automatically configures one audio source for each element of the sounds array. It is quite important to have one separate audio source for each element of the array, so while you can configure everything manually, ignoring our setup functions, you must remember to have one audio source for each sound element. I then assign the reference to the actual sound map we want to use for this component. And after, on the root game object, I'm going to add the final component for the system to work, which is going to be called fSoundAreaUpdater. This will update with the position of the player or the camera or whatever other transfer you're going to place in the player transfer field. It's going to use this position to update the various sound controllers, in this case the river sound. Once you have done this, we can hit play and finally test our sound areas and audio in play. The editor is moving super slow due to video recording, but as we approach the river, we should start hearing the river sound getting stronger. Going back to the fMapArea component, you're going to see a height value to be set. This basically defines the height range that specific map covers. Bottom handling instead defines the behavior at the bottom of your map, actually of the bounds of your map. So 0 will have a 0 value read at the bottom, which will then be interpolated with the above maps, or choosing top map will actually use the values from the first map above the base of your collider bounds. We can also test our values in editor through the fSoundAreaTester component, which we need to add to a game object, place in space inside the bounds of a sound area, define the mapped area to test via its mapped area field, and then using the drop-down menu, test value will fill up the test value field with data read from the map at that position. This is useful to test the gradient of the fade of your map or interaction between various maps or whatnot. It's just a useful additional component. This should hopefully be enough to get you started with the fSoundAreas system. And important to notice is that the base component fMapArea can be used for many different cases apart from sound. You can use it to basically handle maybe, I don't know, wind intensity across your scenario or animals spawning or whatnot. You basically have 3D space relative density maps which can be customized according to your needs.